I want to talk about the quadratic formula, but today's lesson will not be the quadratic formula. It'll be the first step used in the quadratic formula, and that first step is called a discriminant. By looking at the equation for a parabola in general form, you will be able to predict what the parabola would have for solutions. And there are three things that can happen in space. So if we talk about two-dimensional space, we've got XY planes. You could have a parabola, that's just this bent shape here, that never crosses the x-axis. And as we've learned, all your solutions should always come from the x-axis. It has to cross the x-axis. This would be a case where you have no real solutions. And we often call those imaginary solutions. So this would be imaginary solutions. Case 2, you could have a parabola that crosses the x-axis. Now when it crosses the x-axis like this, you have two scenarios. Either it can cross at nice lattice values like 3 and -2, or they could cross at irrational values. So you could either have first rational solutions, and that would be two rational solutions, so that's plural. Or part 2, these could be goofy numbers like the square root of 3 or 5 minus the square root of 2. So you could have irrational solutions. Now, if you have an irrational solution, you always have two of them. There's a theorem, it's called the irrational root theorem. It says if you have one irrational, you have a second. Irrational roots always comes in pairs. Rationals, not necessarily. An example of that would be one of these parabolas that come down. They kiss the x-axis, that's called a double root, and then they go back up, or possibly they come the other direction. They come up, they kiss the x-axis, go back down. They just have one solution. When that happens, it has to be a rational, a single, one rational root. So this is just an introduction of what a discriminant would do. You're either going to have two imaginary, two rational, two irrational, or one rational root. Now how to figure this out, I'll show you in a minute, but I want to give you a little chart here explaining what I'm doing before I jump into the math. So understanding discriminants. How do I get these pictures? How do I get this concept flowing? There's a formula called b squared minus 4ac. It is part of a quadratic formula. b squared minus 4ac. That is known as your discriminant. That is the discriminant. Now, if you do this calculation, which I'm going to show you how to do in a moment, you can go through this chart and you'll be able to determine what picture you're working with. And so, first off, if your result, when you plug these numbers into this formula, you end up with a result that is negative, you know you have two imaginary solutions. That's what we're looking at right here. You've got two imaginary solutions. The parabola never crosses the x-axis is what that means. Scenario 2. If your discriminant turns out to be 0, so you plug some numbers in here and this turns out to be 0, it tells you that you have one rational root. It means you have a perfect square, and you're dealing with this guy right here. Where it's located could be anywhere on the x-axis, but it's going to come down, kiss the x-axis and go back up, or vice versa. It comes up, kisses it, and goes back down. And so that would be if the discriminant is equal to 0. If you have a value of 0, you have one rational root. Now the next two state that if the discriminant is a positive square value, so remember your squares, we're talking 1, 4, 9, 16, 25, so on and so forth, 121, 196, 625, any of those square values, if that is the result when you plug these numbers into the formula, called your discriminant, you will have two rational roots or two rational solutions. And that means it would be something like what I have here. These are rational numbers, -2 and 3. 2/5 and 3/7 are considered rational roots because they're fractions, and when written as decimals, they either repeat or terminate. The other scenario is if you plug the numbers into the discriminant, into that formula, and you get a non-square value, like 3, 5, 7, 15, then that means you would have two irrational roots, two irrational solutions. So those are numbers that when written as decimals, they do not repeat or terminate. And those are actually very, very common. An example of that, I'm just going to write something. I'm not even going to think here. I'm going to give you an example of a parabola. And hopefully this works out, but traditionally when you just write something, you start writing numbers down. So I say something like 2x squared plus 3x minus 5. If you just randomly write numbers, usually you're going to get irrational roots because they are exceptionally dense. They are the most common results. Now, what am I specifically referring to? The form here is y equal ax squared plus bx plus c. To determine the value of a discriminant is equal to b squared minus 4ac. That's all you have to do today. So when you look at this, what is the value of b? It's 3. So I'm going to square it, and I'll say 9 minus 4. The value of a is 2. And the value of c is -5. So you see the calculation is quite simple. So I can say -4 times 2 is 8, or -8. -8 times 5 would be 40. So this would be, of course, I give an example that's going to work out nicely. This will be 49. Now, 49 I recognize as a square value, which means, go to my chart here, if the discriminant is positive, check, it's positive, and a square value, it is square, 49 is square, you see, then I will have two rational roots. You can say two rational roots. And that's pretty typical. When I go to make an example, I get the opposite of what I'm looking. So let's try it again. Let's just make up something. Y equal 3x squared plus x minus 4. Now that's going to work too. How about 14? We'll do 14. How about that? Let's see what happens with that. So my discriminant, remember we're looking at this as A, B, and C values. It is defined, and I would encourage you to write this formula. A lot of times in math, repetition is going to be your best friend. I know you don't like to write formula after formula after formula, but by writing those formulas, you commit them to memory. So if I square this b value, there's an implied 1 there, I get 1 minus 4 times a, which is 3, times -14, which is c. I'm going to grab my calculator here. I don't want to make any mistakes. And I clear this out here. I simply go 1 minus 4 times 3 times -14. And I get 169. Which once again, I recognize as a square value, which means I'm going to have two rational roots. And that's just my luck. As I just randomly throw numbers, I keep getting squares. I promise you though, I'm going to do another one. If you just throw numbers down here, and honestly, I'm not thinking, I'm just throwing numbers down to see what happens. If I go x squared plus 3x minus 13, most of the time, if you were just randomly throwing number after number after number, you're going to end up with two irrational roots. So all I'm doing is looking at the a, b, and c values and then applying this formula. I say the discriminant is going to be b squared minus 4ac. b is 3, so when I square it I'd say 9 minus 4. a is 1, there's an implied 1 there. And c is negative 13. So then I go 9 minus negative 52, which would be plus 52. And when I add that 9, I get 61. So again, I go back to my chart. This is a chart that you're going to want to write down. If the discriminant is negative, no, I was not negative, I was positive. If it's 0, no, I'm not 0. If it's positive, yes, I am positive, but I'm not square. 61 is not a square value. It's a non-square value. That means I have two irrational solutions. And that's all you would write is two irrational solutions or roots. Roots and solutions are synonymous. They're interchangeable. Let's do one more of these here. Let's say I had y equal, actually I'm going to do two more of these. Let's say I have y equals x squared plus 6x plus 9. If I do my discriminant, which is nothing more than b squared minus 4 times a times c. So I wrote it a little bit differently that time. I put parentheses in there. My b value is 6, so 6 squared is 36 minus 4 times a, which is 1, times c, which is 9. 4 times 9 is 36, so I get 36 minus 36, which is 0. Think back now. What does it mean if I have a discriminant that is equal to 0? If you look at your chart, it says if your discriminant is 0, you have one rational solution, which means, right here, one rational root. This is a picture where your parabola comes down, hits the x-axis, and goes back up. That's exactly what's happening there. And then, like I said, let me do one more here. What happens if I have this? Y equals 2x squared plus x plus 20. That's my parabola. I go to my formula, I simply say the discriminant is equal to b squared minus 4ac. b is 1, so I say 1, minus 4 times a, which is 2, times c, which is 20. So I get 4 times 2 is 8. 8 times 20 would be 160. So I get 1 minus 160, which is negative 159. What does it mean if your discriminant is negative? What does it mean if your discriminant is negative? It means you have two imaginary solutions. Two imaginary solutions. Now it seems like this is a little bizarre. Why would we be doing this? This is simply saying you have a parabola that never touches the x-axis. It's part of a process. I'll use this when we do the quadratic formula. If you do a quadratic formula, it's just a smaller part of a bigger formula. You could tell whether you have solutions from the get-go before you even go any further with the problem. If you're looking for real solutions for places where it crosses the x-axis, if this is your result, then you know to stop because you're not going to get any real answers. And so it's just something that's nice to have in your back pocket. It's a nice way to introduce this concept that we're going to get into. And that's exactly what you're going to do for homework. You're simply going to be given an equation. You look at it, you plug it into this discriminant. You look at this chart that I hope you copied down. If your discriminant is negative, you're going to say you have two imaginary solutions. If it's 0, you're going to have one rational solution. If it's a positive square value, you get 2 rational solutions. And if you get a positive non-square value, then you get 2 irrational solutions. In the real world, this is the most common answer. In the classroom, we see a lot of these because we just try to keep you in an umbrella, keep you with nice problems. But this is actually less common than your irrational. Rational numbers are less common than irrational. Irrational should be the most prevalent answer if you're just throwing problems out there, throwing numbers out there. I know the first 2 I did it turned out to be rational, but that was just a fluke. Truly, your irrational solutions from randomly generated numbers would be most common. And so that's your introduction to understanding discriminants, and this is all you need for the homework today.